at Jayoti Vidyapeeth Women's University, Jaipur. Today, I am going to take a lecture on the subject System Analysis and Design, and the session name is Real-Time Systems. Let's start. These are the topics which I have covered in this lecture: real-time system, integration and performance issues, interrupt handling, real-time databases, real-time operating systems, real-time languages, task synchronization and communication, and real-time design. Now come to real-time system. Real-time system generates some action in response to external events. To accomplish this function, they perform high-speed data acquisition and control under certain time and reliability constraints. Because these constraints are so stringent, real-time systems are frequently dedicated to a single application. Until recently, the major consumer of real-time system was the military. Today, however, significant decreases in hardware cost make it possible for most companies to afford real-time systems for diverse applications that include process control, industrial automation, medical and scientific research, computer graphics, local and wide area communications, aerospace system, computer-aided testing, and a vast array of industrial instrumentation. In this real-time system, first we'll discuss integration and performance issues. Putting together a real-time system presents the system engineer with difficult hardware and software decisions. The allocation issues associated with hardware for real-time system are beyond the scope for additional once the software element has been allocated. Detailed software requirements are established and the fundamental software design must be developed. Among many real-time designs, concerns are coordination between the real-time task, processing of system interrupts, I/O handling to ensure that no data is lost, specifying the system's internal and external time constraints, and ensuring the accuracy of its database. Real-time system concerns for software must be applied in the context of system performance. In most cases, the performance of a real-time system is measured as one or more time-related characteristics, but other measures such as fault tolerance may also be used. And the second is interrupt handling. One characteristic that serves to distinguish real-time systems from any other type is interrupt handling. A real-time system must respond to external stimuli interrupts in a time frame dedicated by the external world because multiple stimuli interrupts are often present. Priorities and priority interrupts must be established. In other words, the most important task must always be serviced within predefined time constraints regardless of other events. Now the next is real-time databases. Like many data processing systems, real-time systems often are coupled with the database management function. However, distributed databases would seem to be preferred approach in real-time systems because multitasking is commonplace and data are often processed in parallel. If the database is distributed, individual tasks can access their data faster and more reliably and with fewer bottlenecks than with a centralized database. The use of a distributed database for real-time applications divides input-output traffic and shortened squeeze of tasks waiting for access to a database. Moreover, a failure of one database will rarely cause the failure of the entire system if redundancy is built in. The fourth one is real-time operating systems. Choosing a real-time operating system for a specific application is no easy chore. Some operating systems classifications are possible, but most do not fit into neat categories with clear-cut advantages and disadvantages. Instead, there is considerable overlap in capabilities, target systems, and other features. Now, the next is real-time languages. Because of the special requirements for performance and reliability demanded of real-time systems, the choice of a programming language is important. Many general-purpose programming languages, example C, Fortran, Modula 2, can be used effectively for real-time applications. However, a class of so-called real-time languages, example ADA, Zoviel, HLS, Chill, and others, is often used in specialized military and communications applications. Contribution of statistics makes a real-time languages different from general-purpose languages. The sixth one is task synchronization and communication. A multitasking system must furnish a mechanism for the task to pass information to each other as well as to ensure their synchronization. For these functions, operating system and languages with real-time support commonly use queuing, semaphores, mailboxes, or message systems. Semaphores supply synchronization and signaling but contain no information. Messages are similar to semaphores except that they carry the associated information. Mailboxes, to the other hand, do not signal information but instead contain it. Now the next comes to analysis and simulation of real-time system. In the preceding section, we discussed a set of dynamic attributes that cannot be divorced from the functional requirement of a real-time system. In this, interrupt handling and context switching, response time, data transfer rate and throughput, resource allocation and priority handling, task synchronization and intertask communication. Now another one is mathematical tools for real-time system. A set of mathematical tools that enables the system engineer to model real-time system elements and access timing and sizing issues has been proposed by Thomas McCabe. This is based loosely on data flow analysis techniques. The next is simulation and modeling techniques for real-time system. Mathematical analysis of a real-time system represents one approach that can be used to understand projected performance. However, a growing number of real-time software developers use simulation and modeling tools that not only analyze a system's performance but also enable the software engineer to build a prototype, execute it, and thereby gain an understanding of a system's behavior. Now come to the real-time design. In this real-time design, The design of real-time software must incorporate all of the fundamental concepts and principles associated with high-quality software. In addition, real-time software possesses a set of unique problems for the designer. First is representation of interrupts and context switching. Second, concurrency as manifested by multitasking and multiprocessing. Intertask communication and synchronization. Wide variation in data and communication rates. Representation of timing constraints. Asynchronous processing. Necessary and unavoidable coupling and operating system, hardware and other external system elements. Next is modeling principles of real-time design. There are some modeling principles that should be considered in the design of real-time software. These are explicit atomicity, interleaving, non-terminating histories and fairness, closed system principle, structuring of state. Thank you. This session powered by digital version 2.0 Jayoti Vidyapeeth Women's University. Hope you are satisfied with my digital session. If you have any query, please mention in comment box. I'll resolve it. Thank you.